Far beyond the edge of our solar system, where sunlight fades into a thin, distant glow and the darkness between stars begins, a small machine continues drifting in silence. It was launched in 1977, built with technology that now feels ancient, and never designed to survive this long. Yet after nearly 5 decades, it is still there, still moving, still sending signals back to Earth across an unimaginable distance. That machine is Voyager 1, and it has traveled farther than anything humanity has ever created. So far, in fact, that a single message sent from Earth takes almost an entire day just to reach it, and another day for a reply to come back. Every conversation with it is slow, delayed, almost like speaking across time itself. And despite its age, despite the cold and radiation of deep space, it continues to function, quietly observing a region no human has ever seen before. For most of its journey, Voyager behaved exactly as expected. It sent back data about planets, magnetic fields, and cosmic radiation. It followed the laws of physics like everything else in space. Predictable. Measurable. Understood. Until something changed. It began with a tiny irregularity buried deep in the stream of data Voyager sends home. At first, it looked like nothing. Just a faint disturbance, the kind of noise that appears all the time in space. Scientists are used to filtering out these kinds of signals. Space is not empty. It's filled with particles, radiation, and interference that can confuse even the most precise instruments. But this signal didn't fade. It repeated. And then, it did something that shouldn't happen. It moved. Not in the slow, drifting way of debris carried by gravity. Not tumbling randomly like a fragment of rock. It shifted direction with smooth precision, curving through space in a way that suggested control. Deliberate motion. Intent. That was the moment when it stopped being dismissed as noise. Because in space, objects don't just decide to change direction. They follow forces. Gravity pulls them. Momentum carries them. Radiation pushes them. Everything has a reason, a measurable cause. But this didn't match any known force. Scientists ran simulations, testing every possibility. A small asteroid. A distant comet. A cluster of dust. But none of those explanations held up. There was no tail, no heat signature, no chaotic motion. No gradual drift. Just controlled movement that didn't belong in the natural world as we understand it. And then something even more unsettling happened. Voyager 2, traveling on a completely different path millions of miles away, detected a similar anomaly. The same kind of signal. The same structured disturbance. The same impossible behavior. That was the turning point. 2 separate spacecraft, 2 different locations, 2 independent systems, all seeing the same thing. It couldn't be a malfunction. It couldn't be a glitch. Whatever this was, it was real, and it was happening across a region of space both probes were moving through. As more data arrived, the picture became clearer, and far more disturbing. It wasn't just one object. There were hundreds. Over 300 separate objects, all moving together. Not scattered randomly, not drifting apart, but maintaining precise positions relative to each other. They moved like a formation, gliding through interstellar space with coordination that shouldn't be possible without some form of control. In space, even small differences in speed cause objects to spread out over time. Gravity, radiation, and countless subtle forces slowly pull everything apart. But these objects stayed together, holding their pattern with incredible precision. It looked less like debris, and more like a system. Then came the signals. Voyager's instruments began detecting pulses in the surrounding plasma, rhythmic and repeating. Not chaotic bursts of energy, but clean, structured patterns. They looped, repeated, and followed sequences that hinted at something more than randomness. It was as if the objects weren't just moving. They were communicating. The idea was difficult to accept, but the data kept supporting it. These pulses didn't behave like natural radiation. They carried structure, timing, and consistency. The kind of patterns engineers associate with signals, not noise. And still, there were no signs of propulsion. No engines. No exhaust. No visible source of energy. Yet the objects accelerated smoothly, changing direction without hesitation. Some readings suggested speeds that pushed beyond what we consider possible, as if they weren't moving through space in the normal sense at all. It was almost like they were interacting with space itself, gliding along something invisible, using a method of motion we don't yet understand. Back on Earth, something unexpected began to happen. Amateur radio operators, people with simple equipment set up in backyards and small stations, started noticing faint signals. Weak pulses. Strange rhythms. At first, it seemed like coincidence. Radio interference is common, and most unusual signals can be explained by natural or human-made sources. But when the timestamps were compared, a pattern emerged. These signals were being detected at the same times Voyager recorded its strongest anomalies. The connection was too precise to ignore. Some believed the signals were reflections, bouncing through layers of Earth's atmosphere. Others suggested unknown interactions with magnetic fields. But no explanation fully accounted for the timing and structure. It raised an uncomfortable possibility. Whatever Voyager was detecting out there, part of it might be reaching us. As awareness of the situation grew, changes began happening behind the scenes. Data became harder to access. Certain transmissions were restricted. Communication channels were adjusted. Public updates slowed while internal analysis intensified. Because this was no longer just an anomaly. It was a question with no clear answer. Scientists began searching through decades of archived data, looking for anything similar. Every deep space mission was examined. Every signal reanalyzed. But nothing matched. No previous encounter showed the same patterns, the same formations, or the same behavior. This had never been seen before. And then Voyager itself started acting differently. Its systems didn't fail. They didn't break down. They changed. The spacecraft began rerouting its own processes, accessing memory that hadn't been used in decades. Old subsystems became active again, sending data through unexpected pathways. It wasn't random corruption or damage. The behavior was consistent, structured, almost purposeful. Engineers worked carefully, sending commands across billions of miles, waiting days for responses. Every adjustment took time. Every test carried risk. But no matter what they tried, the new behavior remained. Voyager was still functioning. But it wasn't exactly the same. Some began to consider a possibility that felt almost impossible to say out loud. What if Voyager hadn't just detected something? What if it had interacted with it? The signals in the data didn't look like random noise anymore. They showed patterns that resembled structured systems, repeating sequences that hinted at information rather than coincidence. And Voyager, with its old, quiet, analog design, might have been the perfect receiver. Modern spacecraft are filled with digital systems, constant communication, layers of interference. But Voyager is different. It's simple. Slow. Clean. Free from the noise that surrounds Earth and modern technology. Out there in deep space, far from everything, it listens. And maybe, just maybe, it heard something that wasn't meant for us. Or something that was? Now the questions remain. Are these objects natural phenomena we don't yet understand? Or are they something engineered, something created with purpose? Were they simply passing by? Or were they sending something, to somewhere? And the most unsettling question of all still lingers. If